In our last episode, we talked about SpaceX's upcoming Starship suicide dive, or more precisely, their 15-kilometer hop followed by the belly flop landing maneuver. And we're all very excited about this, including myself. It's going to give us a real indication of how this landing procedure is going to work under real-life conditions. But I also talked about how this test is never going to provide us with all the information we need about how this landing procedure is going to work on Mars, aside from the fact that it's going to be way more difficult. Now, we can, as one of my commenters pointed out, extrapolate the data that we get from Earth and extend it to Mars, but really when it comes down to it, that's little more than guesswork. And when it comes to live passengers, human lives at stake, guesswork is just simply not enough in my opinion. So we talked briefly about alternatives, about fuel depots on the way to Mars so that the Starship would have more fuel for a powered landing. We talked a little bit about the possibility of fuel depots arriving at Mars, a variety of different things. But one thing that I didn't talk about is my favorite solution, and actually after a little bit more research, it's become an even more attractive alternative for me. And this alternative involves putting essentially a lunar gateway in orbit around Mars. It would have the same advantages, the ability to scout out the Martian surface to determine what really is the best landing site, to look for appropriate places for water, for habitation, everything that we need to know without taking the risk of trying to land 200 tons on the Martian surface. But for once, Mars actually offers us an advantage. There are already 2 lunar gateways orbiting Mars, namely Phobos and Deimos, and we can take advantage of these moons in the same way that we can take advantage of an orbiting space station. As a matter of fact, these locations offer more advantages than a space station would. Advantages that I like to call Mars Station Alpha and Mars Station Beta. Hello, and welcome to yet another episode of The Angry Astronaut. I'd like to thank all of you for tuning in as frequently as you do. As you know, I tend to churn out content very quickly, and this is partially because I love doing this, but also because monetization is such a fickle thing, and it kind of goes up and down quite a lot. And if I'm going to make this my career, I need to keep working. But it's a job, and I'm not complaining, and I do enjoy doing it. So thank you very much for that. In our last episode, and by the way, if you haven't seen that, then I recommend you go back. Otherwise, you might get a little bit confused. I talked about something that I like to call the Starship suicide dive and how the 20-kilometer hop is going to relate to it, or 15-kilometer, or whatever that's going to end up being. So what we did is we talked about the belly flop approach, how that's going to work on Earth, how that might not work on Mars, and are there going to be alternatives? Now, once again, I'm not saying that this process is definitely going to fail or that it's deeply flawed or anything like that, but I can't help but wonder if I was on one of the first crewed missions, or perhaps the first crewed mission to Mars. And I was hurtling towards the surface of the red planet at bone-chilling speeds, and excited as hell to be going to the planet that I've been wanting to go to so badly all my life, the most important thing that I've ever done. And yet, at the same time, hoping that the engines light properly, hoping that we don't encounter a dust devil unexpectedly on the way down, hoping that everything goes the way that it's supposed to, the way things have gone with the cargo missions before us, of course, which would have come before any sort of manned expedition. And also perhaps comforted a little bit by the fact that I at least wouldn't have a whole lot of time to get pissed off about things if the process failed before it was all over. Suffice to say that I might actually have a second to ask myself, is there another way that we could have done this? And this is what this episode is about, is an alternative to the Starship suicide dive, belly flop maneuver, whatever you want to call it. And it's a consolidation of a lot of other ideas. An idea from Lockheed Martin called a Martian base camp, which, although I think anything that Lockheed Martin does is going to be very expensive and also take forever to implement, but at the same time, I think that there are some definite pros to their approach. But what it ends up being, as you'll see in the video, is a lunar gateway orbiting Mars. So that being the case, why not use something that's already orbiting Mars? Something that's going to provide protection from radiation, something that's going to provide us with the necessary fuel that we need. And of course, a lot of you probably know where I'm going here, and that's the moon of Phobos, or Mars Station Alpha, as I like to call it. Although in this case, there's actually going to be a Mars Station Alpha and a Mars Station Beta, and I'm going to get a little bit more into detail about what I have in mind. So, in any event, strap in, get ready for our first journey to Mars, and a way that we might be able to make this happen a lot more efficiently and a lot more safely. Even though I'm not a big fan of Lockheed Martin, it is a rather unique and ingenious way of getting the Orion spacecraft all the way to Mars. The Mars base camp is essentially two redundant spacecraft in one, consisting first of all of a cryo stage at either end capable of providing the thrust to take this base all the way from CIS lunar orbit to Martian orbit. The base camp also allows the Orion to detach from the base itself and explore the Martian orbital vicinity, such as Phobos and Deimos. In addition, it has zero boil-off fuel tanks and an oxidizer for the journey to and from Mars, and zero boil-off is pretty impressive technology. The base also has a sizable habitation area because you couldn't expect a few astronauts to survive inside the Orion for 6 months without serious psychiatric help afterwards, and it has a good viewing port, as you can see there, to look at Mars while the astronauts are on board. Kind of a nice feature. There's also a laboratory designed not only to analyze samples brought up from the surface, but also to control robotic servants on the Martian surface in real time, rather than having to pre-program them 10-15 minutes ahead of time as we've had to do in the past. The base also has multiple canadarms, and here's how the cryo stage in the Orion attaches to the base, picks up personnel, and then explores the surrounding Martian environment, such as the moons. And you're going to see that in just a moment, exploring Phobos, which of course would be a huge adventure in itself. Now, since the astronauts would be on the Orion, it would allow them to control probes in real time as they explored Phobos. and this would be a huge advantage simply because we have lost so many probes, or well, the few that we've sent anyway, to asteroids and destinations like Phobos, simply because of light travel time. It is very, very difficult to control a probe that is this close to an asteroid or a moon with this low of gravity without losing it. Real-time control of robotic probes in hazardous areas like this offers so many advantages, not just on Phobos, but also on Mars. It offers advantages that we simply don't have on Earth, given the fact that we have to pre-program the path of rovers minutes ahead of time, and then hope that our pre-programmed routes don't get the rovers stuck. This base offers many advantages, and it almost has me sold. Almost. The problem is that this base is designed to work with the Orion and the SLS. It is not very well designed to work with the Starship. It's not a refueling depot, for example. It actually could probably be transported by the Starship in its fairings in one go. It wouldn't even need transportation all the way out to Mars orbit. Now, it does have a lot of redundancy built into it, and it does have a lot of safety built into it, which are big positive factors, but not if you're trying to transport large numbers of people down to the Martian surface. It's simply designed for a small-scale expedition to Mars, and not colonization. And also, since the Orion cannot land on Mars itself, it's going to require that we build a new lander from the ground up. I wonder how much that's going to cost. Now granted, the lander will probably be a lot smaller and therefore will slow down a lot more in the atmosphere and be able to execute a powered landing because it will have fuel available to it. So it will be able to make a safe landing, but it's not going to carry near the amount of cargo or personnel that we're going to need for colonization. And frankly, on a 2-year journey, I would not want to be one of the astronauts who's left behind on the base camp. Because although the astronauts at the surface are going to have some protection from the Martian atmosphere, essentially exposing them to about the same radiation as the astronauts on the ISS, the ones in orbit are going to be subjected to the same cosmic rays and the same radiation as astronauts traveling through interplanetary space. Not too fun. But a great number of these drawbacks could be eliminated if we put this very same base on Phobos or Deimos or both. And how would this be? Well, let's have a look at both of the moons first. Both of these moons are absolutely tiny by our standards, and Phobos is by far the closest. With an altitude of less than 6,000 kilometers, it orbits Mars 4 times every time Deimos makes an orbit around the planet. Deimos, however, orbits at a distance of about 23,000 kilometers and takes about 30 hours to complete one orbit. Now, the first advantage of using these moons can be found in our good old Delta V map. As you can see, if you squint real hard, Deimos is the easiest place to reach in terms of Delta V, and then Phobos, and then finally Mars. The only thing that evens this out is the fact that you can use the Martian atmosphere to bleed off Delta V, hence the Starship suicide dive. And here's a problem. The Starship is not going to have enough fuel left to rendezvous even with Deimos without the Martian atmosphere, hence the need for fuel depots on the way out. Another alternative would be to use the Martian atmosphere for aerobraking, reducing the speed without actually trying to land until your velocity is to a point to where you can enter Martian orbit, either Deimos orbit, which would be easier, or Phobos orbit, either one. But there is a problem with aerobraking. It would take weeks before the Starship would be down to the appropriate speed in order to enter an orbit. Weeks of time that the passengers would be exposed to radiation and cosmic rays, and weeks for them to continue to consume their supplies. However, this would also be the case if there was a dust storm or some other sort of situation in their landing site. They'd still have to do this in order to enter an orbit rather than trying to brave a Martian dust storm. But think of the advantages this would bring you if you could pull it off. Let's go back to the Martian base camp and look at all of the things that would not be required if you set this up on one of the Martian moons. You wouldn't need propulsion systems, you wouldn't need propellant. All you'd need is habitation and some sort of landing craft perhaps, and of course the solar panels. But a lot of the rest of this would not be required. Instead, you would need something else. You see, we suspect that both of these moons have a lot of water and a lot of carbon, just like C-class asteroids, and that can be used to make Methalox fuel, a whole lot of it. We suspect that there are trillions of tons of both elements on both moons. So these two moons offer just about all the advantages that the Martian base camp has to offer, plus being natural refueling depots on top of that. Another advantage that they have is that you can set up the habitation units subsurface beneath a lot of regolith to protect the astronauts from radiation. On top of that, both bases would still offer real-time control of any robotic probes you sent down to the surface, plus robots that you had in mind to build habitation units. So, all of these 3D printed structures like this one that were supposed to be built by robot originally could be controlled from orbit, allowing for a lot more precision when it comes to the building. And just in case they were to get hung up during the process, then astronauts could be dispatched to correct the problem. In fact, everything we have in mind to create with automated processes in a Martian city can be more easily controlled from one of our orbiting moons, even landing pads for the Starship, which means that one of these stations could send a fully fueled Starship down to the Martian surface, able to make a powered landing on a flat landing pad. And if you want a smaller lander for your station, no problem. As I mentioned in the previous episode, Dynetics clearly has an ambition to use their lander on Mars, as you can see from the top right corner of this illustration. And the Dynetics lander could prove quite ideal for sending small payloads down to the surface, including building things like landing pads for the Starship. Now, a Dynetics lander as is obviously could not be used on Mars. You would need heat shields, you would probably need more powerful engines, more fuel, although you might not need more fuel if you can manufacture it in situ on Mars itself. Still, it's a lander that is mostly complete as it is, therefore eliminating the need to build a new lander from the ground up. And the last factor that makes Mars Station Alpha so attractive is the prospect of dropping a space elevator from Phobos down into the Martian atmosphere. Since Phobos orbits Mars so quickly, it would be impossible to tether it to the ground. However, you could have it terminate right at the edge of the Martian atmosphere. And by the way, this isn't my idea. I have a study linked in the description. But the delta V required to rendezvous with a Phobos space elevator would be minuscule. Considering the rotation of Mars versus the speed of Phobos, you would only have to parallel it at about a speed of 80 kilometers per hour and transfer your cargo or your personnel. Not very difficult, really, considering the types of rendezvous we already do in low Earth orbit. So consider all of the advantages this solution has to offer. Protection from radiation in orbit. Almost unlimited fuel for the Starship to make a powered landing on the surface. Control of robotic systems on the surface so that you can build habitation domes or greenhouses or landing pads or whatever you want. There are so many advantages to this particular method of traveling to Mars. Plus, Look at that unbelievable view. I mean, I'm just about ready to sign up. I just have one question. Which moon is Mars Station Alpha and which one is Beta? So I thought that this would be an appropriate episode for the beginning of October, because after all, at least here in the United States, this is a spooky month for all of us. And to me, there's nothing more spooky than the idea of trying to land on an alien world that's gobbled up nearly half of the spacecraft that have tried to land on it. It's a very scary concept, I must say. And so this is why I come up with these particular ideas. I'm not saying that this idea is the best. As a matter of fact, this is not even really my idea. It's just a consolidation of a lot of other people's ideas, people who are way more intelligent and way more educated than I am, in terms of coming up with an alternative to landing 200 tons all at once on the surface of Mars. And as I said in the video, just like the Lunar Gateway serves as a wonderful orbital base camp for expeditions to the moon, so too does Mars Base Alpha and Mars Base Beta serve as an excellent base camp for exploring the red planet, in my opinion. And this is something that we should be seriously looking at. And I think NASA is, and so I think also SpaceX should be looking to it as well, collaborating with folks who are very interested in getting boots on Mars. And honestly, I think a lot of people at NASA believe very strongly that SpaceX is going to be the first organization that gets boots on Mars before they do. And so I think they very much want to see Elon Musk be successful. They very much want to see a colony on Mars before anybody else manages to do it. So I do believe that consolidating with other folks who have other ideas is ultimately going to be the key to success. That having been said, I'm still enjoying the contents of this coffee cup. I can hardly stop talking about the damn thing. Not because I like it, but because I want to destroy it. And I've recently passed 23,000 subscribers, on my way to 24,000. Thank you very much. I've recently passed 2 million total views. That blows my mind that many people would take out their time to watch me act like an idiot on screen. I am deeply humbled, and thank you very much. And if you want this channel to continue, and as I said at the beginning of the episode, YouTube is fickle. Monetization is fickle. 1 minute I'm making decent money. The other moment, I'm making virtually nothing for my efforts. And so therefore, support from the outside, as much as I hate to even ask for it, is something that's critical to the success of this channel. And that's why I'm continuing to list my supporters and to say thank you to them. And there are many ways to support this channel, and it's all in the description, and I'm not going to talk any more about it. Oh, and by the way, since we were talking about space stations, here's another prop that some of you may have seen. Beep, beep. I don't know if you can see that. Yes, I am a 51-year-old child, but that is the Lunar Gateway as Lego sees it, and it's one of the first props that I ever bought, but I thought it was appropriate for this episode. In any event, until we're ready to make the decision as to how exactly we're going to try to land on this formidable and mysterious world that's fraught with all kinds of dangers, not just in terms of the landing, but also after we get there, I urge all of you to stay angry about space.